Chapter 5, Section 1 is about rate of change. This has two parts, and you, by the end, should be able to find the rate of change, which is also known as slope, from a table, a graph, or an equation. And you should be able to find the slope using 2 points. Okay, the definition of rate of change is something that shows the relationship between two changing quantities, which means we need to find the change in the dependent variables, or the y's, and put that on top of the change in the independent variables, which is the x's. Okay, another way you might see it written, this little triangle means change, so the change in the y's over the change in x. The table here shows the horizontal and vertical distances from the base of the mountain at several poles along the path of a ski lift. The poles are connected by cable, between which two poles is the cable's path the steepest, and how do you know? Okay, so what you need to do is figure out, this is your x and this is your y. You need to find the change between these two. Okay, so I know that this actually goes up 5, and then the change between these two, which happens to be up by 20. Okay, so if you remember from our equation back up here, the y's go on top. So we really, from A to B, we have 5 over 20, which is really 1 over 4. Okay, that is your rate of change for those two poles. Then we try the next one, where we happen to have a change of 25 and 20. So from B to C, we have 25 over 20, which gives us a rate of change of 5 over 4. And last but not least, from pole C to pole D, we have a change of 10 and a change of 40. So from C to D, we have 10 over 40, which is another 1 over 4. So the steepest is from B to C. That one spot on the ski slope is steeper than the other two. Okay, that is finding 3 different rates of change. All right. The marching band. This table shows the distance that a band marches over time. Is the rate of change in distance with respect to time constant? And what does the rate of change represent? Okay, so they actually show you right here the answer to their question. So they were finding the difference between each set of numbers. So they went, the first one, they took the 520 minus 260 to find out that it changed by 260 feet. And from 2 seconds minus 1 second, so that meant that every 1 second, they were going 260 feet. Okay, then they went from 2 seconds to 3 seconds and 3 seconds to 4 seconds and did the same thing, and they found out every time they were moving at 260 feet per 1 second. Okay, that per 1 minute, I'm sorry. That tells us that the band is marching at a constant speed of 260 feet per 1 minute. That is a constant rate of change. All right, this first problem, they're asking you if you get the same rate of change if you use non-consecutive rows of the table. Okay, non-consecutive just means not in a row. So instead of going from first one to second one, we're going to try going from the first one to the third one. Okay, so I'm still going to look for my difference. So I'm going to do 780 minus 260, and then 3 minus 1. And that's going to give me 520 over 2. If I simplify that, that's going to give me 260 over 1. Okay, this is the same table that was back here in the marching band, but they're wondering if it'll be any different. Okay, that one turned out the same. What if we tried these? Okay, so if we do 1040 minus 520 on top and 4 minus 2 on the bottom, that's going to give me, that's going to reduce also to 260 over 1. So if it is a constant rate of change, like we found out that this one was, then it doesn't matter if we use consecutive numbers or not. They're all going to reduce to the exact same amount, which in this case is 260 feet per minute. All right, this table shows the elevation of a hang glider over time. Is the rate of change in elevation with respect to time constant? And what does the rate of change represent? Okay, it appears that this one dropped by 35 feet. This one also dropped by 35 feet. And this one also dropped by 35 feet. And the minute side looks like we're adding 1 every time. Okay, so since these are all the same, we can say, if we do change in y over change in x, we can say that this plane, hang glider, went down 35 feet every 1 second. That is our rate of change, and that's what it's representing. Okay, this would be a good place for you to stop and check out to see if you know what you're doing. They're asking for both of these tables if the rate of change is constant, and if it is, what is that rate of change and what does it mean? So pause your video right here, try these two, and then come back and check your answers. Okay, welcome back. The first one I discovered is yes, that one has a constant rate of change. It's changing every 3 hours. They're getting 1 fence built. The second one is also a yes, and their rate of change is that they are moving 35 miles per 1 hour. All right, so this graph is showing us the relationship between time and distance, and it is linear. When the data is linear, the rate of change is constant. It can't form a straight line unless it's changing by the same amount every time. Okay, this rate of change can be found by using rise over run, which is also slope. Okay, so rise over run is slope. They use the letter M for slope. Okay, so when you have a graph, you can find the rate of change just by finding the rise over the run. Okay, in this case, we have a point here and a point here. We go up 2 units and we run 3 units. So your slope or your rate of change is 2 over 3. Okay, for B, this one is going to be negative because the line is going down, and our rise is -4. Then our run is 5. Now, some of you maybe in your mind wouldn't have drawn it that way. Maybe you would have drawn it this way. Okay, that would have made our rise a positive number, but our run then would have been backwards, so that would have been negative. So either way, you're going to get a negative slope. All right, so what happens if I don't have any points labeled on my graph? You can pick any points that land exactly at a cross, okay? These are chosen for you. So I'm going to draw my triangle and I'm going to rise 2, run 1, 2, 3, 4, 5. Okay, this one, I'm going to rise a -2, run 1, 2, 3, 4, 5, 6. Then I can simplify this to -1 over 3. Okay, so that means I should be able to find another point on this one. If I could simplify it, that means there was another point in the middle, down 1 over 3, right there. But it doesn't matter which points you use because they will always simplify to the same answer. Okay, here's a good spot. Pause it, find the slope of each line, and then come on back and see if your answers are the same as mine. All right, I would choose these 2 points, draw my triangle, and then start counting. My rise is 2, my run is 8, which means that at 1 over 4, I should have been able to find another point. So up 1 over 1, 2, 3, 4. This is another point I could have used. On the second one, it looks like I have a point here and here maybe. Draw my triangle, so I rise -2, run 1, 2, 3, 4. Okay, so I can simplify that to -1/2, which means there's also a good point right there. All right, part 1, you should be able to do page 296, 8 through 16, 23 through 25, and then part of your lesson quiz.